This video is brought to you by Pramp. Pramp is a free online service that allows you to prepare for your upcoming technical interviews. The nice thing about Pramp is that it allows you to practice like you play. The way it works is you sign up for Pramp, which is free, and then you schedule a time that works for you to set up your mock interview. Pramp automatically matches you with a peer at the time that you select, and when the interview starts, you each have 30 minutes to play the role of both the interviewer and interviewee. Prior to the start of the interview, you will be provided a technical interview question from Pramp that you will ask your peer, and your peer will also be given a question that they will ask you during the interview. One of the things I really enjoy about the Pramp service is that it forces you to work under time pressure and also peer pressure, and this is something that you can't quite obtain from just grinding leak code questions or cracking the coding interview problems. So these are great resources, but knowing how to deal with getting stuck in a setting where someone else is watching and assessing you is incredibly valuable, and this is something that really pays off to practice. If you want to sign up for Pramp and give this a shot, please check out the sign up link in the description of this video. Using Pramp is 100% free, but using that link helps support my channel. So if you found my content to be helpful and feel as if you could benefit from the Pramp service, then please sign up and give it a try. In this video, we're going to be wrapping up our series on system design, specifically on the short URL video series, and we're going to briefly touch on the notion of database scaling. And we're going to be covering this topic from a very high level, and the reason for that is because the interviewer that you have for this particular problem, let's say if this is the context in which you're viewing this series, may take this in a number of directions, and going too deep into any of the offshoots of this will probably take us too far afield and will be well beyond the scope of what we can cover in this video. So we're just going to briefly touch on some of the topics that you may encounter or some of the questions that you might touch on in this type of flavored scenario here for database scaling. And then if you want to find out more information on things that we'll touch on like NoSQL or MySQL, if those technologies are not familiar to you, I encourage you to look those technologies up and to see kind of what they're all about in addition to watching this video. And I just also want to mention that this particular series here, this particular section anyway, is inspired by a post from Interview Cake, and I'll make sure to leave a link to that in the description below to this video as well. So with that in mind, let's go on and continue this series. So the first thing that we can ask here is the type of database that we might want to use, namely the paradigm of database that we might want to use for our project. And two different paradigms from, again, a very high level are relational databases, something like MySQL, or a non-relational database, something like NoSQL. So you may or may not have dealt with these technologies or heard of them. And just, again, from a very high level, you can tell kind of by the name, a relational database is a specific paradigm that is quite good at storing the relationships between the data that you store in that database, whereas a non-relational database, as you might imagine, doesn't necessarily handle the relationships between stored data as well. But however, in exchange, it does give you some faster reads and writes and is a bit more scalable. So based on our project, we might want to think about which one of these choices would be a more appropriate paradigm for our project. So for our particular URL shortener, the non-relational approach might offer some better advantages. Again, just from this very, very high level description of the two. And that is namely because we don't necessarily need or see any particular use for the relational properties that happen to be present. There doesn't seem to be anything in our project that would benefit greatly from these relational properties. So it doesn't really make sense to use MySQL as the paradigm. NoSQL might be better because it does offer these advantages for reads and writes and possibly for scalability. So from this high level description of these two paradigms, we might opt for a NoSQL type of database. So, and again, I encourage you to look into both of these two different paradigms, relational and non-relational, and also for these specific technologies like MySQL and NoSQL if you haven't used them or if you don't have any experience in those technologies. So one further optimization that we can actually tag on to our NoSQL database is we can get rid of this unique ID that increments every time we store a new entry in our database. So generally, whenever you store an entry in a database, there's this ID field, which is a unique key for every single entry, and that ID field automatically increments every time you put in a new entry. But what we can do is we can get rid of that unnecessary field because we know that the short URL that we're using is going to be unique for every entry. So we might as well just get rid of that unnecessary column in our database and just opt to have that column, that unique field for our database just be the short URL component. So the extension after the base URL, this part right here, can be the key, and this will save us a little bit from having to store this unique auto-incrementing index field that we would have to store otherwise. So another thing that we can think about with respect to the database is the database read speed. And generally when I say read speed is we want to kind of minimize the amount of time that we perform any disk seek, and we want to try to see if we can store data in memory so that way it's more accessible as opposed to actually reading into the database, getting the data. If we can just store some of the frequently accessed data into memory, this will reduce the number of times that we need to actually read into the database. And as a use case, just as an example, we might imagine some celebrity or maybe someone with a lot of followers posts a short URL, and as a result, that short URL is accessed many, many times, and we get a surge of requests for a specific short URL. So one way we can kind of mitigate that, or one way we can reduce the number of explicit reads to that short URL, is to store something that's very frequently accessed into memory, so that way we can kind of reduce a read for every time this thing is accessed, and we can just access it from memory and optimize that further. So again, this is kind of a high-level idea and something that is definitely beyond the scope of this particular video, but it's something that's worth pointing out and worth mentioning. So on a final note, we can think about some other directions that we might want to take this, or namely the interviewer may want to take this particular short URL project. So depending on the company you're interviewing for and the direction of this project, this could go in a number of different ways. And again, not to reiterate too many times to beat a dead horse, but this is kind of probably beyond the scope of this video. But let me just kind of point out some ideas just to kind of get your mind in the frame of some directions that this could go. So one possible direction is the interviewer might want to ask you how we would go about storing analytics for how many times a link was accessed. So if you have the capability, as we've kind of gone over here, a capability for creating a short URL and kind of getting benchmarks for how many times that URL may be accessed, what if we wanted to actually figure out storing the number of times that link was clicked and displaying that in some type of dashboard to the user? Would we be able to store and kind of present these analytics to a user, and how do we go about doing that? This particular solution does scale, but what if we just wanted to launch something that is very quick, fast, and effective? So think minimal viable product. So what if we wanted to just get something up and off the ground and just get something incredibly simple? How would the framework that we've developed here change? What would the time horizon look like? What would the technology look like? Could we then transfer that into something that would look like something that we've gone over, and what would that look like? One other direction is to isolate failure points. So is it possible to isolate any single point of failure for this approach, for the more general approach? And if so, how do we mitigate against those points of failure? Essentially just be able to sort of figure out what the weak points in any of these things are, and be able to come up with a good solution for how you would mitigate any risks against these types of failure. And again, there's a number of different things that can go wrong, and depending on the company or the interviewer that you are discussing this with, they may emphasize certain points. So these are some other directions, and again, all of these are well beyond the scope of this video, but it's just something to hopefully get your mind kind of oriented the right way to start thinking about these things. So that pretty much does it for this series on the short URL. I'm going to continue to do a few more videos on the system design topic. If you like these types of videos, please let me know. If you want to see any particular problem of system design covered, I'll do my best to try to do a fair treatment of that. If you have any questions or comments or criticisms of this, please don't hesitate to leave a comment and let me know. I'm always trying to improve the content and quality of these videos. So thanks again for watching. I really appreciate it, and I'll catch you in the next video.